There are different ways to graph linear functions, but we're only going to be paying attention to graphing linear functions in slope-intercept form. Whenever an equation is in slope-intercept form, we have enough information to graph a line. The equation in slope-intercept form is when it's written as y equals mx plus b. M is the slope of the line, also known as rise over run, and that's always going to be next to the x. B is going to be the point at which the function crosses the y-axis or the intercept of the y-axis. The slope will determine whether the function is going to increase or decrease. If the slope is positive, you're going to move up and to the right. If the slope is negative, you're going to move down and to the right. For example 1, we're going to identify the slope and the y-intercept. So as we mentioned earlier, the slope is going to be the number next to the x, so the coefficient of x. In this case, that's going to be 5. So we're going to start by writing that the slope is 5. We will say m is equal to 5 because that is your slope. And then we have your y-intercept, and that's going to be the constant, the number that doesn't have a variable, and that's going to be negative 3. So we put b is equal to negative 3. Let's take a look at example 2. Again, we're going to identify the slope and the y-intercept, and the coefficient in this case is going to be a fraction. We have 7 over 4, but also keep in mind that this is negative. So that means that our slope in this problem is going to be m for slope, and that's going to be equal to negative 7 over 4. And your y-intercept is going to be, again, the constant by itself, so that's going to be 2. So b is equal to 2. In this case, because the slope is negative, our graph will be decreasing as we move to the right. In this example, we need to identify the slope and the y-intercept, but then we're going to graph it. Again, we have mentioned that the slope is going to be the coefficient of x, so the number in front of x. Even though the order is changed, this is going to be your slope, negative 3. So let's write that down. M is equal to negative 3. And your y-intercept is going to be 5. So b is equal to 5. Your first point is going to be at the point 0 for x and the b value. So we know that in this case we have b is equal to 5. Therefore our first point is going to be at 0 for x and 5 for y. So that means that when we go to our graph, we're going to start at the origin, and we're not going to move left or right because we're at 0, and now we're just going to move 5 units up. This is your first point. Now, to find the second point, we're going to go to our y-intercept, and using the information from the slope, that is also our rise over run, we're going to move 3 units down because it's negative 3. So 1, 2, 3. And anytime that you have a whole number, you're only going to move 1 unit to the right. So this is going to be your next point at 1, 2. The only thing you need to do now is make a line that connects both points. And your line is going to look like this. We are done with this problem. For example 4, you can see that our slope is going to be a fraction. So our slope in this problem is going to be 2 over 3. 2 over 3. And your y-intercept is going to be negative 4 because that is the only constant, that is a number by itself. So in this problem, we're going to start at 0, -4. So we go to 0 and we drop 4 units. And now we use our slope to find the next point. Because our slope is 2 over 3, rise is 2, and run is 3, we're going to move 2 units up, 1, 2, and we're going to move 3 units to the right, 1, 2, 3. So that is our next point. Now let's make a line connecting both points and put arrows as the endpoints. And we're done graphing linear functions in slope-intercept form.